Video we will use SERIESSUM and LOGEST for Power Law Decay Model of a Maclaurin Series Expansion. Our equation will be y equals a times b to the power x, which is power law, but it's also y equals a to the times exponent cx, where c is ln b. We will generate the data set from this range of x, and we will use 3 for the value of a and zero point 0.3 for the value of b. So RC will be ln of b. Now we'll generate the power law dataset, which is RA formula A times B to the power X. And that's our dataset for the power law. We will regress it using the logest. So logest of data y and data x and show the full statistics. We are regressing this data set with itself. So we have a perfect value, R3, our B0 matches to our A, and B1 matches our B, zero point 0.3. Our standard error coefficient is 0 because we're regressing it with itself. R squared is perfect, 100% or 1. Stay x is 0. And residual sum of square is also 0. Next, we will generate the expansion of this function or power law. The expansion will be A times the quantity 1 plus x ln b plus x ln b squared over 2 factorial plus x ln b cubed over 3 factorial until x ln b to the power n over n factorial. Our values of n will start from 0, incremented by 1. So we generate the n values up to 10 to fill up the data set. And our coefficient, factorial coefficient, will be RA formula over 1 over factorial of the n values. Now we can use series sum to generate the dataset of the expansion, which is RA formula A times series sum of ln b b times the x values, where the power ranges from 0 and incremented by 1, starts from 0, incremented by 1, and our coefficient, factorial coefficient, will be this range. You will notice our dataset in the expansion is almost the same as the dataset of our power law equation. We can regress this. We have using logest of data y and data x. And we'll show the full statistics. You will notice we don't have a perfect value of standard error. It's not perfect 0. Our stay x is not perfect 0. Our residual sum of square is 0, but our stay x not. We can insert this to the chart and show the trend line. Our trend line will be in the exponential form because that's the only available. We don't have a power law trend line, so we use the exponential. Here we have 3 times e to the negative 1.2, which is actually c. negative 1.2x. And we will insert the expansion and show the trend line also of the expansion in the exponential form. You'll notice the expansion has the same trend line equation as the power law equation, even if they differ slightly in the output of the logest, but they still have the same uh, trendline equation because the coefficients are the same.